Hi, this is checkpoint 5.4 from section 5.1. They want us to sketch the left and right endpoint approximations for f of x is equal to 1 over x on the interval 1 to 2 with n is equal to 4, and then approximate the area using both methods. Here are a couple of drawings of 1 over x, and these are the intervals that we're going to work with. But before we actually work with those intervals, let's see that interval kind of up close. Here, just 1 and 2, and then we want 4 partitions, so let's split this in half and then in half again, and then figure out what those values are going to be. So half of this is 1.5, and then half of that is 1.25, and then 1.75. So those are going to be the values that we would be considering. The other thing that we're interested in is figuring out what the lengths of these things are, the delta x, which is going to be the base of the rectangles that we're going to draw, and the base of those rectangles is just going to be 1/4. We can think about that formula where you have 2 minus 1 divided by n, which is 4. That's b minus a divided by n. So 2 minus 1 divided by 4 is 1/4. Let's go ahead and write that as a decimal. And now we're going to draw these things. So let's first draw this from the left endpoint point of view. And so let's see if we can match colors. Left endpoint. And so what we want to do is we want to split this up the way we split up this interval into little sub pieces, and then for each of them we would draw a rectangle, and for that rectangle we would use the left endpoint to be our height. And so here the left endpoint is going to be when x is equal to 1, and I'll give you a height, and then from there the second one we'll do a left endpoint again, left endpoint again, left endpoint again. So it looks like it'll end up being an over approximation. Let's go ahead and write this out. I think the notation is L for left endpoint, and then n is 4, so L sub 4 is going to be equal to, now the height of this thing is putting the left endpoint, so this is x1 or x0, x1, x2, and x3. So putting those values into our function 1 over x. So it's going to be 1 over 1 times so that's the height, times the base is delta x is 0.25. And then we'll add this thing, putting x sub 1 into the function. So it's 1 over 1.25 times 0.25. And then the reciprocal of the next one, 1 over 1.5 times the base, and then the last one is 1 over 1.75 times 0.25. Okay, so the thing is that we can write this in a bunch of different ways. This is probably the most long-winded way of writing it. We can think about factoring out a 0.25. The delta x can be factored out, so we're just adding up a whole bunch of those things. So let me show you that. This is just going to be 1 over 1 plus 1 over 1.25 plus 1 over 1.5 plus 1 over 1.75, and all that times the delta x 0.25. All right, so that's another way of writing it, and an even better way of writing it. That would be more compact, but it'll probably give you the less chances to solve for it if you were going to actually compute it, is to use a summation notation. So this is going to be the sum. I goes from 0 to 3. Notice that it starts at 0, 1, 2, 3, so there's still 4 things that we're adding. Even though we're starting at 0, we're ending at 3. There is 4 things that we're adding. And then it's going to be 1 over x sub I, so x sub 0, x sub 1, x sub 2, x sub 3. And so that's the function times delta x. Okay. Probably saw that formula coming, but in any case, I would plug this into the calculator or computer and end up getting an approximation. So the approximation I got was 0.7595. So that's going to be our left endpoint approximation. Now your actual area looks like it's going to be a little bit less than that. It looks like this is an overestimate, because if you look at these triangles have are all above the graph. Now let's take a look at our right endpoint and do the same thing. We'll split this up to 4 equal partitions like we did here. But then when we create our rectangle here, we're going to use the right endpoint. And so in this first rectangle, the right endpoint is going to be 1.25. So we'll start with x sub 1, and then x sub 2, x sub 3, and x sub 4. So x sub 2, x sub 3, and x sub 4. So notice that the first one didn't pop up. All right. So we'll put it into this formula. This time I'll write it backwards. R sub 4 is going to be the sum. This time it goes from 1 to n, 1 to 4, of 1 over x sub I times delta, or 0.25. That's our delta x. All right. Now we can write it in either way. Let me write it this way. And so we can actually see this and actually compute it. Since n is equal to 4, it's not very, it's not going to be very big. So the first term is going to be 1.25, and you put that into the function, you get the reciprocal of that, 1 over 1.25, and then plus 1 over 1.5 plus 1 over 1.75 plus 1 over 2 times 0.25. Okay, and so that's it. Put it into your calculator and get a value, and our value is 0.6345, and it makes sense. This is less than the overestimate that we had, and so your actual value would probably somewhere in between these two approximations. Okay. All right, I hope that helps.